the number of hours these 80 students spend doing homework, and most of the time the cumulative frequency curve, the graph, like an S letter like this. Question A, find the median number of hours per week these year 12 students spend doing homework. How do we find the median? Please tell me from this cumulative graph. Because there are 80 students in total, half of 80 is 40. You need to take the value 40 here, right in the middle, and draw a dashed horizontal line to the cumulative graph and find the intersection point here. And that intersection point is associated with this value 14. So the 14 here is the median. And you just need to write that answer. The median Q2 is the 40 number, which is 40. Question B, given that 10% of the year 12 students spend more than K hours per week doing homework, for the value of K, 10%. 10% of the students, 10% of 80 students means 8 students, spend more than 8 hours. So subtract 80 by 8, we have 72. Okay, 72 here. 10% of 80 students is 8 students, meaning these 8 students from the student number 72 to the number 73 and so on to the number to the student number 80. Okay, meaning the students who spend most time, the greatest amount of time, more than 8 hours doing the homework. So according to this graph, the number 72 here, this is the point associated with the time 18 hours. So this is K. Okay. Meaning there are 8 students numbered from 72 to 80 spending more than 18 hours per week to do the homework. 18 hours, meaning how many hours a day? 18 divided by 7, including Sunday. 2.6, about 2.6 hours, spending about 3 hours a day studying,
Okay.
Doing the homework. What's your average time doing the homework?
It depends, like 1 hour or something.
Okay. 10%. So that's the method, 3 marks. So the first mark is saying that there are 8 students. 8 students. Number, which is 10% of 80 students, spending more than that. And then mention the number 72 on the cumulative frequency, and the value of K is 18 hours. Okay. 1 mark for naming the number, giving the number of 8 students. 1 mark for the number of the student on the cumulative graph, 72. Yeah. 8 students in the top 10%. 72 students spend less than K hours, meaning number of the student from 73 to 80, spending more than 18 hours. The next question, we are given a table. There are 4 students spending about 2 hours to 7 hours a week, meaning about 1 hour a day. And other frequency, P and Q, we don't know. We asked to find P and Q. Just do the cumulative graph. Yeah, just do the cumulative graph from 21 to 24 here. 21 is here. And go up here. Okay. The number here is 76. So there are 4 students from 76 to 80 spending from 21 hours to 24 hours doing the homework. Okay. Just understanding, just read the graph. Okay, so just read directly on the graph and give the number, which is P is 4. Sorry, Q is 4. And P, you can do it similarly. Take the number of students, the cumulative frequency in the number of 15, and then subtract the cumulative frequency for the students spending 7 hours. Or you can do it the other way. 80 subtract the sum of other numbers. Okay.
Yeah.
80 subtract 16 plus 4 plus 4, 24. Wait, that is a lot, huh?
Yeah. So
Anyway, we check
56.
it with the community graph. This is 24. 80 minus 24.
50, 56.
56. Oh, that's a lot. Let me check that with the cumulative graph.
All right.
7 hour. 7 hour is here. This value is 4, and 15 is here. 15 is here. And associated with this value is 60. So you see, 60 minus 4 is exactly 56. Okay. This 15 hour is associated with the cumulative frequency of 60. Okay. 60.
Okay.
And then the cumulative frequency of 4 is associated with 7 hours. So the difference is 60 minus 4, 56. The same with the other method. So we very confident that this is a correct answer. And so most of the students spends about 7 to 15 hours per week doing homework, meaning about 1.5 or 2 hours. Huh? That's a reasonable time.
Okay.
Okay. So according to this question later, I would suggest other students to spend about 2 hours a day studying, doing homework.
Just 2 hours doing physics every day.
Question D. Estimate the number of year 12 students that spend more than 15 hours each week doing homework. More than 15. So you just need to take the total number 80 and subtract 60 here, huh? 20. Estimate 3 marks. Wow, 3 marks just for one
But I said that there are 320 students in year 12 at this school.
Okay. Sorry. Okay. We can do the percentage. From this cumulative graph, there are 20 students spending from 15 hours to 24 hours per week doing the homework. Huh?
Yep.
It means 20 over 80, 1/4, 25%. Okay, 25%. And take that percent, 25, multiply with this number of students, 320, we get the number of students. Okay, among there are 20 over 80, which is 25%, 0.25. Just right, 25%, huh? 25% student among the 80 student spending from 15 hours, huh? Spending more than 15 hours doing homework. So the expected value, we can say expected or the estimated value, huh? The estimated or expected value of the number of students in 200 among 320 students, huh? Is 25% multiplied with that 320.
80.
Yeah. Spending more than 50 hours. Just writing, a short-term VTech, huh? Is
Yep.
425 multiplied with 320. One fourth of this, 1/4 của 300 là 120, xong rồi 5 nhân 300, từ từ phải có tính 1/4, mình chia 4 đi, có 20 chia 4, tại vì mình không có calculator. 32 chia 4 là 80. Ok, add calculation, huh? 80 students. Okay, estimated here. Wait, okay, D here. Yeah, 80. Yeah, the same method. Yeah, exactly solution, huh? 56 and 4 and 80. And the same mark also, 1/4, 25%, and the multiplication, 25% of 320, and finally the result, 3 marks. Huh? The bracket here means a hidden step, so you can combine many steps in the single formula. Okay.
Okay. Okay.
Question E. Explain why this sampling method might not provide an accurate representation of the amount of time all the students in the schools when doing homework, because the school can have the student of the grade 10, grade 11, even some school they combine with the secondary school. Huh? So the sample here is only taken for the year 12 student the last year, or not exactly last year for some system, but because they didn't take the number of students from other years, like year 10, year 11, and therefore this sample does not represent the population. Okay.
Yep.
Can insert text there? Okay, here. Question E1. Because the sample was taken or carried out only for the year 12 students, but not other years 10 and year 11 students. Hence, it does not represent, it's not a good presentation, or it does not represent, certainly, very likely. Okay. Represent all the students in the school. Okay. Not to mention that a year 12 student, they could be under more pressure, and therefore they have to try doing the homework more often than other years.
That is very sad. It's like comparing BP students to like grade 9.
Okay. Student more appropriate method suggests a more appropriate sampling method. Just 2 marks. But anyway, we need to describe the method. And I'm thinking of what's the word for that? Sampling technique. I forgot the English word for that. Sampling techniques.
Convenient sampling?
No, it's not convenient. Stratify. I'm thinking about this.
Oh, yeah.
It means you have a percentage, a quota. Like how many percent of students. For example, in your school, there are 30% of students in the grade 10, 30% in grade 12, and 40% in grade 12, 13. So you need to take the sample with the similar percentage. For example, you take the 100 people in that sample, 30% in that 100, meaning 30 people must be from the grade 10, 30%, 30 people from the grade 11, and 40 people from the grade 12. And that technique with the quota, with the percentage, is called a stratified sampling. Okay. And also, you need to combine this stratified sampling with the random sampling. But actually, the term stratified sampling already involves the random sampling. It means in the grade 10 students, you take 30%, but in the sample, meaning 30%, 30 students, but randomly, okay, among like 200 grade 10, year 10 students, okay, random sample for each stratify each component of the sample.
Okay.
E2 stratify sampling method. It means number of students, the percentage of students, the sample involves a similar percentage of students from other years with the percentage of all the students in the school. Percentages. For example, 30% of the sample from year 10, 40% from year 4, year 11, and 30% from year 12. And in this year, students are taken randomly. Okay. Stratify something service in all year. A lot shorter than my answer. Okay, I worry about 2 marks, so that I use the description to ensure that it was 2 marks.
Okay. Okay, this is a pretty easy question. Oh, not so easy question.
A function trigonometry. We have enough time to do all these final 2 questions.
Yep.
Consider function that is a trigonometry function. The following diagram show the graph. Of course, adding a constant 6 behind it, just shift the graph upwards vertically. The graph F touches the axis at the point A and B. The shaded region is enclosed by the graph with the x-axis between the points A and B by the x-coordinate of A and B. Okay, x-coordinate meaning this function equal to 0. Let that function equal to 0. Fx equals 0, which means I can make 6 a common factor, 1 minus cosine x equals 0. So the cosine x must be minus 1. When the cosine is minus 1 using the unit circle, the cosine x is here, minus 1 is here. So that angle is 180 degrees, which is pi. Or we need another point. This point A will be pi, okay? The other point will be minus pi or 3 pi, because the period of this function is 2 pi, and the domain is from 0 to 4 pi, and therefore this point is 3 pi, okay? The period is 2 pi. So the second value, 3 pi, is the first value pi plus the period 2 pi, okay? Okay, you got it?
Yeah.
Here is 2 pi. Checking, of course, very confident there, pi and 3 pi. The second method is take the derivative and let it to be 0, because that derivative is the gradient of the graph, and at the 2 points A and B, the gradient is 0. And they are the turning points, the minimum, okay? But that second method is a little bit more complicated, not really necessary. The easiest way, just use the function equals 0. Question B. Show that 3 marks, 1 mark for writing this formula, 1 mark for writing this one, and finally the 2 solutions.
Okay. So we kind of have to remember the unit circle for this question.
It's a very useful tool. Show that the area of the shaded region is 12 pi. For this area, we have to do the integration. Question B. Integration of this function. from A to B, meaning from pi, lower boundary, to the upper boundary, 3 pi. Huh? The function is 6 plus 6 cosine x dx. I can bring the number 6 outside the integration, okay? From pi to 3 pi. Inside is 1 plus cosine x dx. And then I split the two integration from pi to, or if you already practice enough with the integration, you can quickly determine this integration to be x plus sine x, huh? From pi to 3 pi, and then plug the value into this. Okay. Integration of cosine is the sine. You can check that with the formula. The last topic here, sine. Okay. Plugging into it, 6 3 pi minus sine of 3 pi. Again, the unit circle. The sine is the vertical axis, and therefore 3 pi, 1 pi is this point, 2 pi is this point, 3 pi is this point. The sine of 3 pi will be 0. Okay? Sine of 3 pi is 0. And then sine 3 pi. And then you subtract the second boundary, huh? The lower boundary, subtract pi and subtract sine of pi. Sine of pi is also 0. Okay, let me make this just a normal bracket, not a square bracket, huh? Okay, sine 3 pi is 0, sine pi is 0, so that basically 2 pi minus pi, 3 pi minus pi, meaning 2 pi multiplied with 6 is 12 pi. Exactly the thing that we need to prove. Okay, I will send you a link to practice with the unit circle. I love a website like Khan Academy or this thing, Varsity Tutor. There's another website called Transom. Okay, Transom unit circle. But it will provide the response like, okay, like this one, huh? It provide the answer below. When you so you can check your answer or see the solution if you have you don't know how to do it. Okay, this is the link. I suggested to practice a little bit more with the unit circle, huh? To remember the special value for special angles such as 45 degree, 60 degree. Sometimes I feel kind of interested, like a doctor diagnoses the disease of student and giving the recipe of the practice. Okay, yeah, this is also beautiful practice, unit circle. The right cone in the following diagram has a total surface area of 12 pi, equal to the shaded area in the previous diagram. 12 pi, the area. The cone has the base of 2, the height h, and the length height l, by the value of l. Very simple, huh? Just give you the formula in the sheet about the cone in topic 3. By the value of l, we are given the total surface area. This total surface area is the area of the base added with the area of the curve surface, the surrounding. Okay, the base, so we can write the formula. That area, the cone total area, is the base, which is the circle area, which is pi times 2 square. R is 2, huh? The radius 2 square, and added with the area, the surrounding area, which is here, the curved surface, pi RL. Okay. I R is 2, and L is what we need to find. And we're given that this area is 12 pi. 12 pi. Simplify this thing. 4 pi plus 2 pi L. 4 pi. So 12 pi here, subtract 4 pi here is 8 pi. 8 pi equal to 2 pi L. So divide 2 pi, huh? We have L equal 4. Done. 3 marks, 1 mark, 2 mark, 3 mark. Or 1 mark for the formula, replacing the 2 here by the letter R. Pi R square plus pi RL. Okay.
Okay.
1 mark, 2 mark, 3 mark.
Not that hard.
And find the volume of the cone. Use the formula here. 1/3 pi R square times height. Okay, we need to find the height first.
Yep.
According to this diagram, the height is one side of the right triangle. Therefore, we can use the Pythagorean theorem to find the height. Square root of L square minus 2 square, or the radius square. L is 4. 4 square is 16. 16 minus 4 is 12. Square root 12. Okay. And the volume, 1/3 of pi R square times x. 1/3 pi R is 2. 2 square times the height, square root of 12. Okay?
Yep.
Simplify this thing. Square root of 12 can be written as 2 square root of 3, because 12 is 4 times 3, and the square root of 4 is 2. Okay? So can we simplify this thing? 4 times 2 is 8. 8, 4 here times 2 here is 8. 8 pi square root of 3 over 3. Okay. Here, 8 pi over square root of 3, all this thing. Anyways are accepted.
Okay.
That's weird. I cannot erase with a button on my pen. Used to do that and it's very convenient, but now I cannot do it. Okay, trigonometry, geometry done. The last one about function, I assume that there's a question about derivative also. Yeah,
Yeah,
definitely at the bottom, derivative and then probably integration. Particle A travels in a straight line such that its displacement s meters from the fixed origin up to the t seconds is given by that formula. The time is from 0 to 10 seconds and shown in the diagram. The particle A starts at the origin and passes through the origin again when the time is p. Here, p. Find the value of p. That is when the distance s is 0. So just let this function to be 0 again. S at p is 8p minus p squared equals 0. Simplify this thing, making p common factor, a minus p equals 0. And of course, we cannot choose p at 0, the starting time. We have to choose p equal to 8. So at 8 seconds, the particle is returns to the origin again. Okay? Very simple, 2 points. 2 grades. Value p, done. Question B, the particle changes direction when the time equal q. Change direction. Here, at the top here. It's the distance and the radian of this position function is the velocity. And therefore, at the top, the tangent of this graph is 0. Which means the velocity changes from positive on the left here to negative on the right here. Okay. So P is at the top of this parabola. There are 2 ways to do that. One way is simply find the vertex of its parabola. The vertex. The position of that vertex, x coordinate of that vertex, meaning Q. Q is minus b over 2a. B is 8. B is 8. And minus of that, divided by 2 times a is -1, huh? It is 4. Or we can understand it much simpler like this, because P here is 8. The vertex must be the midpoint between 0 and 8, because this is a symmetrical parabola. Okay?
Okay.
Symmetrical parabola. So that is one way, which is the simplest one. The other way is taking the derivative and let that derivative to be 0. But the value of Q. Okay, so how do we show the work, write the solution? That was like 2 marks, huh? 2 marks for this question. Okay, we can write Q is when X is maximum. Q is the time when S is maximum, or at the vertex of the graph, huh? So Q equal P over 2, the symmetrical thing, or minus B over 2A equal minus 8 over 2 of minus 1 equal 4 seconds. 2 marks. Solution B, substituting the value Q into that integrating way. Now, recognizing the particle change direction V0, local maximum, minimum, vertex, parabola. Okay, vertex accepted, huh? Okay. Question B2, find the displacement of the particle from the origin when the time is Q. Displacement, okay, just plug the value 4 into the original formula here to find the position, huh? Very simple. Even this is the last question, huh? Yeah. How many marks in total here? It's 14. At least we can get 8, huh? At least. Okay. That position displacement at the time 4 is the original function here, 8 times 4 minus 4 square. 8 times 4 minus 4 square. 8 times 4 is 32. 32 minus 16 is 16. The position, the vertex is 16, okay? And therefore 16 meter forward, 16 meter backward, and 20 meter here at the vertex here, 16. And so the distance, the total distance is 16 plus 16 plus 20, 52, okay? 16 meter backward, 16 meter forward, and 22, 52. 52. The second particle B travels along the same straight line such that the velocity is given by the second formula here, which is a linear graph. For the time greater than 0, when the time is k, the distance traveled of the particle B is equal to d. When the time is k, the distance traveled of the particle B is equal to d. We're given the equation of velocity, a function of time, which is linear, 14 minus 2t. You understand already that the 14 is the y-intercept, right? And,
yep.
And the intersection here is 7. When this thing equals 0, 14 minus 2t equals 0. So 2t is 14 and t is 7. T7 here. This is the graph of velocity versus time, and the area under this graph is the distance the object travel. It could be only the area on the top here, but I have just calculated that that area, the triangle on the top, is 1/2 of the base 7 multiplied with the height 14. And that area is 49, which is less than 52. Okay? 52 is the d distance. And therefore, the object has traveled another area at the bottom here. When the velocity changes direction, going backward, going forward to the right, for example, and then return to the left, decreasing the velocity to 0 at this time, 7 seconds, and then reversing the direction, going backward, and moving another distance of 3 meters, 53 minus 49, 3 meters. is the distance that the object travel backward, the bottom part here. Okay.
Yep.
That area, the bottom part, is the base, 1/2 the base. I assume that this time is x. Could be 8 seconds or 9 seconds, I don't know. This x value is what I need to find. Okay. That base, the area is 1/2 of the base. The base is x minus 7. The difference, for example, x is 8 seconds. So the length here, the base of the triangle, the small triangle here, is 8 minus 7, which is 1. Okay.
Okay.
And the height is this length. This length is the absolute value of the y coordinate. This is the speed at the time x, and it is a negative value, and therefore I have to take the absolute value of the vx at that time, and vx, I put x into this formula, so that is 14 minus 2x. Okay, and this area equal to 3 here.
Okay.
Solving this equation, because I know for sure that this 14 minus 2x is a negative value. Vx here is negative. So to make it positive, I simply just reverse it, meaning 2x minus 14. Okay? When I have in front of it, x minus 7 equal 3, making 2 the common factor, and then divide 2 in front of it. Divide 2 in front of it. So I have x minus 7 multiplied with x minus 7 is 3. Okay? So here, x minus 7 all square equal to 3. Therefore, x minus 7 is the square root of 3. So x is 7 plus square root of 3. This is the solution. Find the value of k. The time is k. Okay. X there is k. Okay. Please replace the letter x by letter k. K here. Okay. K, 2k, k, 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 k. Got it?
Yeah. Wow, this is pretty hard.
That's the last question. It's supposed to be difficult.
We also use that formula from the formula booklet, the one for distance. I'm just guessing. I'm not even sure if we can use it.
Can you say again?
Can we use that one formula from the booklet from 5.9 to find the distance?
We have to calculate the area of the triangle anyway. There's no other way. For this kind of question.
Okay.
Hello? I've checked the max scheme. There's no other way.